We have the battery, Yuasa 12 volts motorcycle battery. We're going to make a project using this battery. This is 12 volts. We are going to turn on this 220 volts lamp LED. 220 to 240, 3 watts. Philips. 3 watts, 220 volts, 50 to 60 hertz. 220 to 240 volts AC. Using a 12 volts battery. 12 volts battery, this is DC, direct current. But this bulb is AC, alternating current. We're going to turn on this bulb using the 12 volts. How can we turn on this? How to turn on this bulb? 220 volts using 12 volts DC, 220 volts AC, by using this transformer. This is 12v-220v model 38012 transformer, 3 ampere, 0, 110, 220. So these two lines, they are 220, 0 to 220 volts primary. And then for the bionic, and for the secondary, we have center tap 0, the center tap 1212, the left and the right, made in RP. So using this, we're going to turn on this bulb. And also we need a circuit. This is the circuit we need. So aside from transformer, we need this circuit using 4047 IC with potentiometer and some and capacitor and jumper wires mounted on the breadboard. If this is 220, let us check this one. This is 220, this socket. Let us check the bulb if that is 220. Okay, set to AC. And then let us check the outlet. It's 240.2 volts AC. So this is 240 volts AC. And if we're going to, if we check the bulb, so this is 220 volts lamp or bulb. But it works only on AC. Here, we're going to use DC to turn on this 220 volts bulb using this oscillator and transformer, and then the battery. Let us check the circuit. Let us first test the circuit, this oscillator. Let us first test the battery. What is the voltage? Set to DC. Okay, DC. Positive, negative. 12.06. That is the voltage of the battery, 12.0706. So and then we now connect to LED, and then the circuit, connect the battery, so our circuit is an oscillator. So when one is on, the other one is off. If this one is off, the other one is on. We can adjust the blinking by turning this potentiometer. So there is we have this pulse oscillation. In figure 1, we have the 4047 oscillator, a schematic diagram. This is now our circuit. So here we have this 12 volt supply. And then this is our IC 4047. What is this 4047 IC? This is a stable multi-vibrator or multi-vibrator. It is capable of, it can do PWM signal. That is a stable multi-vibrator. It can produce PWM signal. And the output is in pin number 10 and pin number 11. And we have this circuit 4.7K in series with the red LED. This is an additional circuit as a power LED, so that we can monitor that the circuit is on using this circuit. So this is additional circuit. It is not included in our demo. So pin number 4 of the IC, 5, 6, 14, they are all connected to 12 volts. Then 7, 8, 9, 12 to the ground. And then 10, 11 is the output. And then pin number 3 connected is the potentiometer. 1, that is the pin out or the pin of the potentiometer. Pin 1 of the IC connected is capacitor C1104 or 0.1 microfarad capacitor. A small capacitor connected to 1 and then to 3. Pin 3 here is hanging, and pin 2 is the wiper of the middle of the potentiometer for 500K. Our potentiometer, which is connected the wiper to pin number 2 of the 4047. If this is our potentiometer, this one is the pin 1 potentiometer, pin 1, 2, 3, pin 1, 2, 3, pin 1, 2, 3. 3 is hanging, 2 is in the middle. Okay? 2, pin 1, pin 2, pin 3. 1, 1, 2, 2, 3, 3. That is our potentiometer. And then we connect an LED here, just to visualize that it is an oscillator for visualization. LED 1, 2, they are blue. blue LED. When this pin number 10 is on, this one is off. That is the characteristic of a stable multi-vibrator. So when this is on, the output is a square wave on, and then this one is off. If we connect that, on, off, on, off, on, off. Okay, they are happening at the same time. When this is on, this is off. So this is on, this is off, on, off. When this is now on, this now becomes off. So they are alternately flashing or alternate blinking of LED. One is on, one is off. If the other one is off, the other one is on. That is the characteristic of this 4047 IC. It is capable of producing dual LED flasher, or in short, this is an oscillator. It can oscillate on and off continuously because this is a stable multi-vibrator. No triggering pulse, just oscillating by itself. So that's why the whole circuit is an oscillator. This is where we are going to use this circuit as a driver to the upcoming circuit, or we can use this as a driver board to our we're constructing we call that inverter. We are constructing an inverter by 12 volts, converting it into 220 volts, or approximately 220 volts. From 12 volts to 220 volts, we're using this circuit. Here we go again. Instead of connecting the LED, we now we're going to use the oscilloscope. So the oscilloscope probe is connected to the output of the IC. Let us see the output to the our oscilloscope. Channel 1 and then channel 2. The frequency is 4.34 up to, if we're going to adjust the potentiometer, it will go up to 97, 104 hertz, 115, 124. So we can see, let us see the close-up. We can adjust the potentiometer up to 174 hertz. And then you can see here, if I'm going to adjust again the potentiometer, so the frequency, we have the frequency of up to 150, 130, 191 hertz, 300, 191. By looking at this square wave, if we're going to adjust the offset, when the output is off, the other one is on. So if this is on, the other output is off. So they are inverted. One is on, the other one is off. Okay? And we can adjust it up to 218 hertz. Let us adjust that to 60 hertz because we're going to use a 60 hertz signal. So I'm adjusting the potentiometer 60 hertz as a triggering signal to the inverter. That is 60.81 hertz. One is on, output pin number 10 is on. When pin number 10 is on, the pin number 11, this blue, pin number 11 output is off. So you can see that on, off, on, off, on, off. We have now a new circuit. So we are now connecting a MOSFET via 330 ohms resistor to the output of the 4047 pin 10, and then another MOSFET connected to the resistor to the output of pin number 11 of the 4047, and into the drain or the output side of the MOSFET we connected the LED, just to show that we are working with MOSFET. What is now the role of the MOSFET here? Act as a driver of the LED. And the frequency used for this circuit is still 60 hertz. So let us connect the supply. So you can see here all these two LEDs turns on because actually they are oscillating at a high frequency of 60 hertz frequency. That is the oscillating frequency of this LED. And we could not see the blinking because it is very fast, 60 hertz, 60 cycle per second, the oscillation. So when we have 60 hertz, that is the LED output of 60 hertz. And because of this circuit, we're now going to, this is now our driver board for our inverter, for our project. This is now the driving board for our project. The 4047 connected to the MOSFET. 407 act as a triggering signal to the MOSFET. And we tune the frequency to 60 hertz. And the output is LED blue. And they are oscillating. We could not see the blinking because it is a fast oscillation. Oscillating very fast. That's why we could not see the blinking of the two LED. Now we have the MOSFET connected to the output of 4047 via 330 ohms resistor. So what is the use of the resistor here? This serves as biasing resistor. So when the output, we have LED output to the drain to the source drain of the MOSFET IRFZ44N and channel. So we are just going to demonstrate how this MOSFET works. So when pin number 10 is on, pin number 11 off, as we know already. When this is on, it will the current flows into the resistor, and then since this is voltage driven device, it develop a voltage at the gate, causing the gate to open. When the gate opens, now the current flows into the resistor LED, then to the drain to the source, then to the ground. This serve as a switch, this drain to source. And the purpose of this IRFZ44N MOSFET is it serves also as a driver, LED driver. So when pin number 10 is on, due to our PWM on signal, it produces a voltage. The voltage will develop at the gates, causing to open the gate. It is not the current that can make the gate to open. It is the voltage developed at the gate, since this is voltage driven. So the LED turns on, and at the same time this is off. So this one is on, this is off. The moment that it reverse the signal, this one now is on. Now this MOSFET is off, so this one now turns on, causing this to open the gate again, and then current now flows into the next LED. It turns on now this LED, and this one now is off. When this is off, this is on. Then current flows into the drain to the source, then to the ground. But we have seen the LED as they are both on, because of we call that pass switching. And the frequency used for the output, since this is the output, is 60 Hz. And 60 Hz is 60 cycle per second. And 1 Hz is equivalent to 1 cycle per second. So 60 cycles of switching this MOSFET on off. We could not see the blinking of the LED because it is very fast. So as you can see, the LED turns on and the light is steady. We could not see the blinking because of the 60 Hz, 60 cycle. If this one is 1 cycle, you see the waveform, square wave, that is 1 cycle. On, off. 60 of that, 60 times of this signal on off is just how fast is this switching goes on, the switching of the MOSFET. So they continuously switching on and off, on and off, on off. That is very fast. This one sometimes on, this one is off, on, off, on, off. So we can see the LED as a steady light due to the fast switching of the MOSFET. This is now our new circuit. So we remove the LED, 2 LEDs, the blue LED, and then we now connect the transformer. So The 4047 IC now serve as a triggering. It gives a triggering signal. It provides a signal to the MOSFET, and then this MOSFET is serve as a driver of the transformer. Transformer driver, this MOSFET. It gives the oscillation, the 4047, to the MOSFET and then to the transformer. 407 MOSFET transformer. That is the connection. Let us connect the supply. Then we're going to measure the output of the transformer using this AC output, because this secondary stepping up. We connect the transformer in reverse. So this is the output, 184.3 volts AC. We could not achieve the 220 volts. The circuit has no load. That is, the circuit has no load. 100, again, this one or that one. 180 84.7. You can see in the tester. Let us now connect this 220 volts lamp. Okay, 3 watts to the transformer as an output. We have now the bulb connected to the transformer as an output. Let us now connect the power. So you can see here, the lamp turns on. Let us measure the output with load. It becomes 131, 130.6, 131.4. We now come to the full build of our circuit. Inverter, 12 volts, battery converted into 220 volts using 4047 IC with the MOSFET IRFZ44N and channel MOSFET. So the function of this 4047 is it serves as a driver that provides the PWM signal to the two MOSFET. So this is provides triggering signal to the two MOSFET, and then this MOSFET is the transformer driver. So you can see here 12 volts connected to the center top of the transformer, and the drain is connected to the one side of the transformer, and the other side is to the second MOSFET, drain of the second MOSFET. So whenever it receives a positive signal or on, it will turn on the gate, open the gate so that the current, or turn on the gate, or switching on this gate and then current now flows into the from 12 volts to the pin number 3 center tap, then to the transformer, to the drain, to the source, to then to the ground. We now have this rotation or movement. This is counterclockwise. So counterclockwise, CC, counterclockwise is negative voltage. Okay? So we have this negative voltage. Since we are a square wave inverter. Then, at the same time, this is now still, when this is on, this is off. Okay? How about when this is on? When this one is on, current flows into the biasing resistor, then switching on this gate, and then current flows from 12 volts to the center tap, then to the drain, to the source, then to the ground. You can see here, it's a clockwise rotation. So this is positive voltage. Counterclockwise, negative voltage. Clockwise, positive voltage. So, if this is happening at the same time, okay, when this is on, this is off. When this is off, this is on. So, we are creating this center tap as a ground. Okay? Creating that. So once the voltage induced to the first secondary winding, this is actually a transformer connected and reverse. This is supposedly step down transformer. Now, since we connected this transformer in reverse, this is now step up. So this will step up the voltage, inducing the voltage here. This is now the ground. So that's the waveform. And then positive waveform is something looks like this. And then it will off. This one will now trigger this second since we first we have a negative voltage. I think we have negative voltage, this one. If this is negative voltage, that it must be look like this. Negative voltage. This is 0 or the ground reference. Okay? And then the second one is a positive voltage. So you can see here, the ground is in the center. That is the center tap, referring to the center tap. So we have now this AC, which is, I think, equivalent to 184 volts AC. Square wave inverter. But with lamp, so now if we connect the lamp, it becomes 131 volts AC. But we did not achieve the 220, but still we can able to turn on the 220 volts lamp. That is our main purpose or main goal, objective, to turn on the 220 volts lamp. Okay? With load 131 or with lamp connected lamp 131. Without lamp, it is 184. And this is the waveform. This is square wave inverter. Inverter, from 12 volts, it becomes 12 volts DC, DC to AC. 12 volts DC. In actual, we got 184 volts AC. In actual, closer to 220 volts. So that is the function of the 4047 and then the MOSFET. 4047 giving the PWM signal. When this is on, this is off. When this is off, this is on. And then to the transformer, due to the windings, we produce this negative voltage. And then the other one, positive voltage. So this is a positive voltage, negative positive voltage. So this is now in between. This is the center tap that serves as the ground. This one 0, the ground, and the counterclockwise negative, clockwise positive voltage. So we now turn on the lamp using this circuit. A 12 volts battery can turn on a 220 volts lamp. Philips 3 watts, 220 volts. Now connected to the transformer, the output side 220, and then the other side is connected to the terminal block of this our module, and this module will be connected to the 12 volts. So from 12 volts to the module, our inverter circuit, transformer, and then the bulb. We're going to connect now the battery. So it turns on the LED lamp. If I'm going to adjust the potentiometer, it flickers the lamp. So we're just going to adjust the